Hello children, we are studying about combination of resistors. Now actually what does this mean? We connect electrical appliances, might be the electrical bulb, tube light, etc. to a wire. Now in the combination which you want to have, you may have a series combination or you may have parallel combination while connecting appliances, or you may have mixed combination. Normally series combination is normally for decoration of bulbs, etc., in which in the same wire you put a lot of electric bulbs, and the bulbs are connected end on. So have a look like this. A wire comes out, this is a battery I have shown or a cell I have shown, but normally the positive terminal goes to the positive socket of the plug and the negative goes to the negative. So that's an electrical source which is supplying, say for in our house there is a 220 volt, it is supplying, say for example, only 6 volt. Now the wire goes and it goes to the first bulb, it is connected end on like that. And in series combination, this is series combination. In series combination, what happens if one does not work? So this is actual diagram and this is the symbolic diagram. So if one does not work, suppose this does not work, so it is an open circuit, the current will not flow, so everything will be flop. That means none of the devices will work. So that is what is series combination. So, and since same number of electron come and with the same speed, so the current supplied to each of the devices will be the same. So each of the resistors, devices will also term it as resistors, so R1, R2 and R3, these are the bulbs kept, and there is an end-on combination, and I current comes and I ampere currents goes to the each of the bulbs. And but voltage, suppose 6 is there, it can be divided into V1, V2 and V3 is 2, 3, 1 or 1, 2, 3, whatever way, or 2, 2, 2, whatever way possible. So voltage gets distributed because voltage is the push which is needed to pass the electrons through any of the devices. So now this is what is series combination. So you have to remember, in series combination resistors are connected end on. The current remains the same to each of the resistors, through each of the resistors, but the voltage gets distributed among the resistors. There can be 3, 4 or 5. So I take around, I want to derive, like suppose I have to replace this whole the series bulb by one bulb which has got the equivalent resistance of all of them. Then what will happen? Can I get a formula? Yeah, we can. We know that V total voltage is equal to the voltage across each of the resistors, but we also know that total voltage will be total current, and suppose I replace all R1, R2 and R3 by a capital R resistor. So V1 will be what? V1 will be, using Ohm's law, V is equal to IR, current through R1. So current I is only going because same current flows, so I R1 plus in the second I R2 plus third I R3. Current will remains the same, so I have to take I amperes of current. So what will happen? IR will be equal to I R1 plus R2 plus R3. It would have been unending. I is cancelled, so R is equal to R1 plus R2 plus R3. So how do we recognize a series combination? Only thing is, are they connected to the same wire? There is no branching, then that means the resistors are in series. Alright, there is no other way for the electrons to move, they have to pass through the same wire. Now suppose it's very simple that if I have got 5 ohms, say for example there is a question, I make it little complicated, and there is a question. So say for example there is a question that there is 6 ampere flowing and this is 2 volts, 2 volts say for example, and this is 4 volts. Alright, so then what is the total voltage? So what we will do is 1 second, 3 ohm, sorry, the resistor is 3 ohm, 2 ohm and 4 ohm. So what is the total voltage? Find the value of V. So we first find out R, equivalent resistance 3 plus 2 plus 4 ohms, that is 4 and 2 6, 6 and 3 9, resistance is 9 ohms, and we know the total current will be same for a 6 amperes. So we know V is equal to IR, that means V is equal to 9 into 6, that is 54 volts. We would have done it another way around. V is equal to IR for this. So 6 3 is 18, 6 2 is 12. So 18 plus 12 is how much? 18 plus 12 is 30, and 6 4 is 24. So 30 plus 24 is how much? 54. Are you following what I am telling? V is equal to I into R. So voltage here will be current into resistance. So 6 3 is 18. So IR is 18 volt. 6 2 is 12. IR for here is 12 volt. And IR for here, that is V, is 24. So you calculate, so everything comes to 54. Or you can add them up because this is a series combination. So total voltage is how much? Total voltage is how much? Total resistance is how much? 3 into 6 and 4. 3 into 5 plus 4 is 9 ohms. So 9 ohms into the total current is 6 because same current will go. So it is 54 volts. So that is how we also take it up, that in series combination the equivalent resistance is greater than the largest of the resistors. The largest resistance is 4, but our answer equivalent is 9. So this will be helpful when you are trying to combine resistors to get a desired result. Thank you.